Hi, ladies and gentlemen, this is Mrs. Hoekstra. We're going to start off with our first lesson in our first module. It's an experience in relationships as measuring rate. I'm on page 2 of our book. You'll see the essential questions up there at the top of the page, and I want you guys to write in the following questions, all right? We're going to write in, how is finding an associated rate, wow, big word. How is finding an associated rate or unit rate, how is that helpful when making comparisons? When making comparisons between quantities. And ran out of room, didn't I? Oop. How is finding an associated rate or unit rate helpful when making comparisons between quantities? Now, if you look at this first example, it says, how fast is our class? Well, last year, I had a group of students. We timed out how quickly we could pass papers out. All right, and we took a timer and we timed it. I had 27 kids in my first class, and it took them about 15 seconds. That's pretty fast. I was pretty impressed with that. Then the next class, I had a few more kids. I had 31 kids. Well, I have more kids, so it took just a little bit longer, but not a lot longer. It was 16 seconds. And then my third class, yeah, there was only 29 in that class. It was a nice size class as well. And it also took them 16 seconds to pass out all their papers. Okay, well, these are two different things we're comparing, and we need to kind of talk about some of these crazy math words that mathematicians we use all the time. So let's talk about what's going on here. First one is called a ratio. Now, a ratio is just a pair of numbers, but there's an order to it, okay? So we're going to call it an ordered pair. An ordered pair, in other words, the order matters, of non-zero and non-negative numbers. Non-zero and non-negative numbers. Okay, so if you take a look up at that chart, it talks about a ratio. Now, there's several different ways we can write a ratio. A ratio could be written as 27, and then you literally write the word to 15. That's the order that I gave it to you, so that's the order you're going to write it in. You could also write it as 27, and then you put the little colon, the 2 dots, and then the 15. Both of those are acceptable. All right, so 31 and 16, I could write that as 31 to 16. Or, of course, I could write it as 31 and then the colon 16. What do you think I'm going to write then for that next one? I'm going to wait here a few seconds, let you fill it in, and see if you and I get the same answer. All right, so hopefully you filled it in. I write that is either 29 to 16, or of course I could write it as 29 and then the colon 16. And you actually say this colon 2. You actually, what you wrote in words above it, that's how you would actually read that and say that, 29 to 16. All right, so that's how you write a ratio. Pretty straightforward, pretty easy, but you know, we use vocab terms all the time, but maybe not necessarily know exactly what they mean. The next one is the word rate, right? Rate is a ratio. That thing that we just did, yeah, that's what a rate is. It is a ratio, but this time it's of 2 different quantities. It's of 2 different quantities. All right. Notice if you go back to the problem that I gave you, it's about papers and time. Papers is one quantity, time is a different quantity. All right, and so that's what that's referring to. Now a rate, you would actually probably think of it, it would look more like what you would call a fraction. Right? Looks like a fraction. And ratios written this way, we can write it as a rate, and it does look like a fraction. We don't even have to simplify it or anything. We literally write 27 over 15, right? We can write that. Same thing for the 31 over 16. It looks like a fraction. It's a ratio. We're relating the number of papers to the time. So I'm going to give you a couple seconds here. Fill in what you believe would be the rate for the third class. All right, hopefully you just wrote down 29 over 16. Okay, next comes the unit rate. Now for the unit rate, we're going to actually take the rate that we just had, and we're actually going to calculate what it would be if we only had one of those things, right? How many papers could that class pass out in 1 second? If we only had it in 1 second of time. So this one is the value of the ratio. All right, and this basically is meaning when the second value or the second quantity, right, when that second one is 1. That's what I want to know. So instead of having to be 27 over 15, it's what over 1. All right, so you're going to grab your calculator. I've got to find mine. Where's my calculator? Hold on 1 second. I'm going to grab my calculator. All right, I grabbed my calculator, and now I'm going to take that 27. I'm going to type it in on my calculator, 27, and then that fraction bar. I know that that fraction bar also can mean divide. So I'm going to divide that by 15, and I find out that my answer actually ends up being 1.8. Right? I'm going to do the same thing for the second one. I'm going to take 31, and I'm going to divide by 16, and I get, ooh, that's kind of a not so nice number, but I'll write it down. 1.9375. It's going to take me 1.9375 papers. I can pass that many out in 1 second, almost 2 papers a second. All right, I want you to do the next one on your own. I'm going to give you about 15, 20 seconds to try that one. So when I calculated the one to number 3, and I'm not telling you how I did it, but I got an answer of 1.8125. So I could pass out 1.8125 papers in a second, right? Just about 2. So really, if you look at these 3 classes, they all were about the same, right? They were all pretty close to each other in the terms of how quickly they could get papers passed back. All right, I'm going to go to page 3 now. There's page 3. And we're going to talk about the classes by gender, right? How many guys and how many girls, boys and girls, are in these classes? So in my first class, I have 14 boys, and I have 11 girls. Now check out this word here. It says, what is the ratio? Ratio. What did I say ratio was a minute ago? Oh, it's comparing 2 different quantities. Okay, and how do I write that? Oh, I could write that with that colon thing, right? That's what I have on that other page. So I'm going to come over here. I'm going to write 14 to 11. Right? My second period class, My second period class, I have 12 boys and I have 12 girls, right? I could write that as 12 to 12. Remember I said that's what that colon means. It's just the word 2. But I could simplify that like you would if it was a fraction. I could write it as 1 to 1. In other words, for every one boy in this class, there is one girl, right? All right, my third hour class. My third class, I have 17 boys and 16 girls. 17 boys, 16 girls. All right, this time I'm going to write it differently. I'm just going to write 17 to 16 just because I can. It means the same thing. All right, case 4, my fourth class. Let's see, what could I do with that one? Well, my fourth class, I didn't have very many boys in there. I only had 8 boys, and I had 16 girls. So how could I write that ratio of boys to girls? Well, I could write it as 8 to 16. But remember, I said we could reduce it. So for every one boy, there are how many girls? Yeah, there's 2. There's 2. For every one boy, there were 2 girls in that class. All right. My fifth class of the day, I had 15 boys and 16 girls. Right? 15 to 16. Can I reduce that? No, there's nothing in between 15 and 16. They're what is called relatively prime. I can't reduce that. All right, how many kids did I teach that year in 7th grade? Let's grab the calculator. I grab my calculator. I'm going to add that up. 14 plus 12 plus 17 plus 8 and another 15 boys. I had 66 boys that year. I'm going to do the same thing for my girls. Let's add that up really quick. I had 11 plus 12 and then another 16 and another 16 and another 16. Wow. I had 71 girls that year. So if I said, what's the ratio of all of my students across the entire day, right? I have 66 boys to 71 girls. Okay, awesome. I want you guys to come down here where it says exercise 1. It says, which is the better buy? All right. When it says there's an exercise, I'm going to ask you to pause the video. I want you to try it on your own. When you're done, go ahead and hit play again, and so you can check to see if what I did is the same as what you did. Give it a try. The only one who's going to know if you got it wrong is going to be you. It's okay. Go ahead and hit pause right now. Try this problem on your own, and then hit play when you're ready. Okay, so now that you've done this one, a pack of 30 pencils, right? Which one's the better buy? I do this all the time. Okay, which one's going to be the better deal for me? So I could pay $7.97, right, for 30 pencils. That's the ratio, which is $7.97 over 30. Well, how much does it cost for just the one pencil? So I take my $7.97 and I get 27 cents for one pencil. All right. Well, what if I bought a 12 pack instead, right? I'm going to buy 12 pencils in a package because I know maybe I don't need all 30, but I still want the best deal. So I'm going to do the same thing. 12 costs $4.77 at the store, but I was getting 12 in that pack. Right? Oop, I wrote that as a right, didn't I? Let's erase that. Crazy me. Let's redo that. So I took $4.77 to the 12 pack, or 4.77 divided by 12. And when I do that, it costs me 40 cents per pencil. So which one's the better buy? The 30 pack or the 12 pack? I'm going to say the pack of 30 was the better buy per pencil, right? It's better to buy the pack of 30 because, that's what that BC stands for, because it costs 27 cents each. That's a bad cent sign. 27 cents each, which is cheaper than 40 cents each. Oh, there's the bell that says class is done. I will see you guys tomorrow. All right, ready to go. Thank you.